So we are going to be doing for object at center of curvature. So to do this, we are going to be drawing a straight line which is known as the principal focus. So let's share this line. I'm going to be using 2 centimeters this time. From this point to this point, we have 2, another 2, another 2. Okay, so once you are drawn, you label it CFP. This is center of curvature, this is the principal focus, and this is the pole. So on the pole now, we'll draw our spherical mirror on the pole. We're going to be drawing our spherical mirror on the pole. So make sure it's on the pole so that we will get good results. Okay, make sure it's on the pole. Okay, so this is it. This is my mirror. This is my mirror, my spherical at center of curvature. So this is the center of curvature. So the object is going to be on C. So I'm going to be drawing my object on C. This is C. Okay, so this is my object. Okay, this is my object. Okay, the rule is still the same as for parallel ray. After reflection, it will pass through the principal focus. This is the principal focus. Okay, so now let's do this for parallel ray. This is parallel ray. Okay, rays that are parallel to the principal axis would, after reflection, pass through the principal focus. Okay, so this is my ray. Okay, so after reflection, it's going to pass through the principal focus. So we have this, this and this. Okay, this point will connect. So this is it. So this is what we have after reflection. So the next thing is the ray will be passing through the principal focus. After passing through the principal focus, okay, after reflection, it becomes parallel to the principal axis. Okay, so we have this. We're going to be connecting this point, this point, this point, this point, this point. You have to be careful, because any small mistake, you will not get the correct answer. So this is it. So then we have parallel ray this time. Okay, so we have, after reflection, it becomes parallel, right? So we have this. So this is the point. Connect it. Okay, so you can see this is the point of intersection. So at the point of the intersection is where the image is formed. This is the point. So we connect it. You can see this is the point. This is the point of intersection. So we have this. Okay, we have this. So this is where the image is formed. Okay, so what can we say from these characteristics now? What is the image? We can then say that the image is, okay, for object at center of curvature, the image is what? You can see that it's the same size as the object. One, the image is same size as the object. Sorry, I'm managing space. Then two, what can we say? The image is formed at C. It is formed. The image is formed at C. Okay, at the center of curvature, the image is formed. This is C here. Is formed at C. Then what can we say? What is the third characteristics? The image is inverted. You can see it's upside down. It wasn't formed upward like the object. So it is upside down. So we say it is what? Inverted. Then what is the fourth characteristics? The fourth characteristics is that it is real. For the fact that the image was formed in front of the is formed where the object is formed, it's considered to be real. Okay, so now let's look at when the object is between C and F. Let's draw a line. So if we draw a line, a straight line, which is our principal axis, let's draw a straight line. Okay, I'm going to be using 2 centimeters again. 2 centimeters plus 2, we have 4, plus 2, we have 6. So these two lines, we have CFP, center of curvature, principal focus, and then the pole. the mirror will be drawn on the pole. Okay, so we use the protractor to do a curved surface on that particular line we have seen to be what? Our mirror. Then we have this. Okay, we shade it. Okay, so the next thing we say object between C and F. So it means the object is going to be between this and this. So we'll draw a straight line between C and F. We'll have this. Okay, so this is the object between C and F. We'll have object. We label it object. So parallel ray, you should be used to it now. Parallel ray, we'll draw a parallel ray first. If we do this, put your arrowhead, what will happen now? From what you have seen before, it will pass through the principal focus now. The ray is going to pass through the principal focus. So we have this. Can you see this? So what is the next thing? Now the ray now we are going to make it to pass through the principal focus now from the object. Ray passing through the principal focus from the object. We have this point and this point, right? This point and this point. So this is it. Okay, put an arrowhead. After reflection, what will happen? Okay, it will be parallel to the principal axis. Let me do it this way so that you can see. It will be both parallel to the principal axis. Make sure it is parallel. So we have this, right? So I'm going to elongate that one. You can see it's not meeting. So I will elongate it so that it can meet, because if it doesn't meet, image will not be formed. So it's meeting at this point. So it means image is formed at this point. This is where the image is formed. So if we are to do the characteristics from what we have, don't forget to put your arrowhead. Image is what? 1. Image, okay, yeah. So let me elongate my principal axis downward. Let me extend it. So this is where the image is formed. We won't have a line on it already. The image is formed at this point. Okay, so if you look at this, this is the object, this is the image. Even without measuring, look at my image. It's about 2 centimeters. Why this one is less than 1 centimeter? What does it mean? It means the image is magnified. What is magnified? It means it is bigger than the object. Then 2, the image is formed beyond C. The image is formed what? Beyond C. That means at the back of C. Beyond C. It's formed beyond C. Then what is the third characteristic? It is what? Inverted. You can see it is upside down. It's not facing the same upward direction like the object. So it is inverted. Okay? And then the fourth one, it is real. The image is real. It is formed on the same side as the object. So it is real. So if you look at all these characteristics, for object before C, you see that it is diminished here. Then after being diminished, that's smaller, it became the same size. Then later it became magnified. So it means that as you are shifting the object, okay, the image becomes bigger. Okay, now look at this. Image is formed between C for object at C. Here it is formed at C. Here it is formed beyond C. Okay, so for these 3 different positions, they are both inverted, they are both real. You should know for these 3 locations on principal axis that the image is inverted, real, yes, for the 3 positions. Okay, now this one, for the first position where the object is before C, it is small. Then for the next position, when you put the object as center of curvature, it's same size. And after when the image becomes between C and F, the image is magnified. I'm still Bukola Joseph, the physics enthusiast. I hope you enjoyed today's. I'm still Bukola Joseph, the physics enthusiast. If you enjoyed today's video, please comment, like, and share. Bye.